Linear programming deals with the maximization or minimization of a linear objective function subject to linear constraints where all the decision variables are continuous. The linear objective and constraints consist of linear expressions. The constraints are expressed as equalities or inequalities with linear expressions on either side. The decision variables, being continuous, take their values from the set of real numbers. Restrictions on their values that create discontinuities are not allowed. In linear programming, nonlinear terms, for example, the multiplication of two or more variables, exponents, logarithms, and absolute values, are not permitted. Here's a typical symbolic representation of a linear program. The model starts with the objective, namely to minimize a linear function of x. Here, C is the vector of objective coefficients. Next follow the constraints, as indicated by the words subject to. The constraints are in the form of linear expressions required to be greater than or equal to a constant, where B is the vector of right-hand side constants. After the constraints come the variable domain. In this case, that all the variables should be greater than or equal to 0. This symbolic representation is often written in short form as shown here. Here, C and B are vectors containing the objective coefficients and the right-hand side values of the constraints. A is the matrix of constraint coefficients and X the decision variables. This table summarizes the characteristics of LP model elements where x, y, and z represent decision variables. The objective function must be linear. The first unacceptable example contains a bilinear term, namely x times y, while the second unacceptable example contains a logarithm. The constraints must also be linear. Inequalities must be of the form greater than or equal to, or less than or equal to. Strict inequalities such as strictly less than or strictly greater than are not allowed. In LP, all decision variables must be continuous. The unacceptable example defines the domain of the decision variable to be 0 and 1. This defines x as a discrete variable, which is not allowed in LPs.